Welcome to the session. Greeting of the day. In today's class, we are going to see about the applications of NDT techniques. We know there are the mostly used top 8 NDT techniques such as this visual inspections and then liquid printed inspections, matic particle inspections, radiography, ultrasonic, acoustic emissions and infrared thermography. And we have studied this all type of inspection methods with respect to its principles. Now we are going seeing the general applications of these all techniques in day-to-day life of aerospace, railways, offshore automobile industries, petroleum projects, and then in this today's class we are going to see about these NDT applications of NDT technique in coal mining industries, and also in this boiler fabrications and welded constructions and castings. So one by one we will cover. Coal mining industry. NDT and evaluation methods are widely used in coal mining industries to ensure, we know, to ensure its quality. Generally, it is the principle, the main objective of this NDT subject is belongs to maintain the quality by doing inspection that we know. So, same, the freedom of mining equipment from harmful manufacturing defects. So the defect should not occur. Free defects automatically increases the quality too. A control of service and environment related defects. So when fabrication is not the only point where the defect occurs, but also you will get defects while the machine setup is in service. Therefore, to control those environment which forms the defect and also the environment which forms the defect in fabrication. So both in fabrication and also in service we are in the position to maintain quality by reducing or eliminating or repairing those defects. So providing a warning systems for prevention and control of accidents and dust controls we can able to do in the mining industry. So majorly in the mining we know the word, it is very related to the underground process. So there may be muds, lot of sands, lot of dust will be there, and lot of accidents also will happen when we are doing the digging process inside. The whole systems will fall down due to vibrations, right? A lot of losing of lives are happening. We are seeing, we are hearing those accidents. So it is our duty to warn them. So this is what the data, this is what the range of working conditions. So this is, we are exceeding the limits and it should not be. So likewise we should warn and prevent and the control action to be taken to avoid those accidents and the dust controls. The mining industries use a hosting system for moving a personnel and a material in a vertical and inclined shaft through the cage, that we know. So through the it means through the rope systems. The rope haulage systems is used to transport men, material and waste, because we are cleaning, digging process takes place. We want to take all those things. We are burying and taking those golds and all precious materials from the coal mining sectors only. So those things we have to take all sands outside, all waste materials outside, and we have to transport here and there, inside and outside. The employees should go in. For all those things we are using a rope connected, a tight rope connected, strong rope connected system, and there's a chance of failure in those ropes also. So it's to be periodically to be inspected, then it is we will get a good quality and maintenance. Its service life will be increased. The system uses items like suspension gears, pulley shafts and steel wire ropes. Yes, the transportation systems the transportation systems either by hosting or haulage are required to be reliable and safe during the services. the components of system show manufacturing fabrication defects like, so there are as like casting defects, as like welding defects. Here also few defects I have noticed here. Here see cavities, porosities, shrinkage in the castings, and the same lack of fusion penetrations as like in the weldings, lappings, laminations in, as like in the base material defects, and all irrespective of all surface and subsurface defects in the welded items. So this lack of fusion, lack of penetration, porosity is all related to welding defects. During service, so this all this belong to maybe fabrication. During fabrication itself, it may, during fabrication of the material, during casting or during joining of the new material, it may come. Now that new material is subject to the service. It went to the coal mining industry. It is working there. The machine setup is doing its job to take the muds or to dig or something. It is doing its job. So at the time, it is subject to in service. The equipment is subject to wear, or it may be subjected to fatigues. Due to fatigues, the crack may form, that is called as fatigue cracks, or maybe definitely it may call this corrosions, as because it is more related to sands. So it will definitely erosion will takes place there on the surfaces. So those things are all in service defects. Effect of various defects depend upon there. So this corrosion, erosions, or otherwise this all these things will form with respect to their locations, or maybe how far its constraints occur, whether the inspector can go inside to do inspections, or otherwise the sand particles are high, what is the ability, those how much friction occurs, how much wear they taken place. Depending upon that, the defect sizes may increase. So depend upon the locations, depend upon the service constraints, depend upon the weather conditions, the environmental constraints, whether it's a wet environment or hot environment, right? Always a very cold environment. So depending upon that also, the various defects will change. Definitely this creates the stresses also. So stress factors also will change the pattern of defects. To ensure serviceability of components and assemblies, it is important to document acceptable defects depending upon their morphology. So we are creating a record to maintain what type of defects are happening in this particular environment, in this particular specific location type. So those we have to, depending upon the, we are recording depend upon the size, number, or proximity of defects or volume, how large it is happening within this environmental conditions. So this we have to record. Then we can identify by maybe by trial and error or by surveying takes place. We can see if we are doing such a job, definitely it happens to such defects. Then we may not do those type of defect creating works. So we may avoid that. So there is a few photos I want to show you how the employees are working there. See how difficultly the tough conditions they are working. So underground digging, coal mining processes. There are few inspectors or employees are having their aprons and they are working towards the field. It's a field work. Say the installations and those piping connections are they are giving. Similarly, they have to inspector also along with them. Inspector also they have to do this type of tests. It's very difficult. They are going inside. We have a yoga treatment, something. We have some talents to be there. In as usual, the oxygen level will be very less. So it is very difficult to survive there. Regarding technically, all type of NDT methods are used here. You see, the following NDT methods are regularly used in this coal mining industries. They are maybe the all points you see, a visual inspection to detect surface defects. Similarly, the magnetic particle inspection to detect surface and also near subsurface defects, because when it is subsurface we can go deeper also. Those things are not possible in the magnetic particle. Definitely those things are possible in the radiography and the ultrasonic. So that is word is near subsurface defects, only on the ferromatic materials. So procedures are common. The location is different. Location is aerospace, location is railways, location is automobiles, location is coal mining zones. Otherwise, the liquid penetrant test to detect the surface defects, eddy current test to detect the surface and subsurface defects, and last we have a radiography and ultrasonic to find importantly the subsurface defects in casting and also the weldments. We are repeatedly seeing our NDT techniques is much more related to this welding and this casting. Life cycle maintenance of components and assemblies requires a periodic examination depending upon say periodic. Here and there we should do to maintain quality on the workplace. Accessibility, field conditions, availability of the equipment. You see, these all three interrelated. So field conditions, we should do inspection at maybe in summer, and again we should do inspection on winter, or every 3 months. Periodic differences may come due to with respect to temperatures, or maybe the accessibility to be there to reach those conditions may or may not be possible. So availability of the equipment also. So what are the equipment we are doing? We have to go deeper and we have to do this visual inspection with the remote aid of video cameras. Otherwise it is not possible to do. At that time we want the availability of video camera setup. Then only it is possible to do those inspections. Such conditions may be available. Often times more than one complementary test may be required. Often one or two continuously we are doing. Feedback from which such a test may be used to risk assessments and allowing some defects in case of economic reasons, or maybe realistic assessments of remaining life components and assemblies. So sometimes we may not do those inspection at that specific point because of maybe from the because of economic reasons, and also if even those breakage or even those failure occurs, it will not affect the component much more. In such cases we left as it is, no problem, because it is having does not have that much impact on the working of the component. So it may be at some corner, it may be a small corrosion because on the thickness of 25 thickness plate or 25 thickness pipe, those small 5.05 corroded zones may not affect this time, may affect after 5 years. So those things we don't bother in the preliminary inspection stages or periodic inspection stages on the first year and second year. But at the same time, those defects will be taken care in the next years, third year and fourth years. So similarly, some respective various economic reasons, we may lift those things. We may not do those inspections depending upon the risk assessments also. Otherwise, if the defect is long over at the Burj Khalifa height, we may not do daily inspections there. Periodically, every year, we may climb there at the top of the tower and we may do inspection. This is what happening in real also. Now we come to safety in the coal minings. Even though the inspections and all those things we are doing, we have to be taken care of safety also in the coal mining, because I already told it is having a low oxygen level there inside those zones, coal mining zones. So such human factors also to be taken care. You see, with increased focus on the safety in underground coal minings, it is necessary to monitor parameters that affect the safety and health personals. So maybe some few parameters. You see what I told, oxygen content it is given. It's a third point. A parameters required for regular monitorings are a gas concentration, maybe number of toxic gases will be there. So what are they? Or gas concentrations we have to be verified for sure. Underground water level, how much? If it is we are going for coal mining at underground level and 150 meters height or something at the ground level, if immediately if it water comes, what happens to the employee who works there? So we have to verify those things. Gas concentrations, underground water level, oxygen content, dust level, how much it is of roof pressure, how much it may fall down immediately. We are keep on digging and going deeper. The rooftop may be imbalanced and it may fall down. Possibility of toxic gas emissions also there. So these are the cases we have to keep remember doing while doing the coal mining treatments. Yes, it is irrespective of NDT techniques. All these points to be in terms of safety. Real-time video monitoring can help. So how we can do the safety instead of doing directly contacting the employees? Such times we can do the real-time video monitoring can help removing the miners to save the areas and protect them from the danger of roof falling. See, roof falling the word. Room and pillar miners requires a long distance connectivity for voice location video processing to locate and help the miners in distress. So we need in between also long we cannot able to roof long roof cannot dig and we can't able to work also at the time. So because this all this stresses are there, life stresses. Oxygen level is come, when the roof may fall we don't know, right? So at the time maybe the gases, toxic gas, where it comes don't know, where it waters will comes we don't know. All these things are stress factors related to our life. Therefore we need somewhere the some rooms and pillars to make rest ourselves during work, during activities. So that's one of the safety factors irrespective of NDT methods. NDT method is technically what method we are using, but employee is, as employee is concerned, we need safety to go there, then only it is possible to do the inspection. A great danger in any mine disaster is a low oxygen level, yes, a high carbon dioxide level. So this two are makes a death factor. Even low levels of carbon monoxide and methane gas, a mixture of nitrogen and carbon dioxide, is equally dangerous as they cause suffocations and death factors. Effects need to be made to install electric gas monitors and other warning systems for detection may help in doing avoiding such circumstances. We can able to immediately supply for oxygen. Occupational lung diseases like silicosis reduce lifespan of miners. So therefore, importantly, this reduction in oxygen and increase in the carbon dioxides make the lungs damages. Okay, so this to be handled. So what we are doing to reduce these things, analysis of nature, size, and volume per cubic metric of dust is essential. And also, in the routine-based dust analysis is also made, and innovative dust control mechanisms also installed over there in the coal mining industries. So dust analysis to be done, and also some dust control mechanisms to be installed there in such a way the employees can be saved. So importantly, the nature, environment, circumstances to be monitored. Those are the important parameters to be focused. The NDA can play a significant role in these areas through applications of available methods and through dedicated R&D efforts. So we need some R&D there to cooperate how to reduce these death factors. NDT inspections of now I am coming to some other types. Coal mining is okay. Right now we will a little bit talk about this NDT applications in pressure vessels constructions also. It means applications we are seeing few parts or a few zones we can discuss. See, a hardness measurement using ultrasonic testing and eddy current testing. Welds in the construction, definitely the subsurface defects. We have seen in early classes defects in welding. So there are nearly more than 20 defects in welding we have seen, and also similarly the defects in casting also we have seen. So those things all to be detected and rectified only it happens through maybe this 8 important techniques. And welds in services by ultrasonic. Maybe in the fabrication conditions we are using radiography, but at the same welding conditions we are using when it is in service, when it is started to work, we are using a ultrasonic inspection methods. NDT inspection of a heat exchanger and condenser techniques are, what are the techniques we are using of NDT in the heat exchangers or maybe the condensers? See, like examples of tube integrity by using eddy current and ultrasonic testing, maybe thickness measurement we are using this ultrasonic testing, maybe a thermography, infrared temperature measurement conditions we are using it, infrared thermography, maybe in the in-service or maybe in the fabrication conditions. And also we are doing some in the NDT technique, we are using some leak testing also to find any leakages of waters or tanks. Maybe in the applications like in railways, we have seen generally as railways, aerospace, those this pressure vessels. So applications few we are summarizing. In railway systems, the safety and reliability totally depends upon the defect-free critical component. Yes, we agree. So see, whenever the components are free of defects, it runs smoothly. Otherwise, it creates problem, it creates accident, create losses will happen. Since from the beginning, the development of railways, they are always prone to be various in-service failures. Fabrication they do properly, everyone, but the defect happens when it is in service. Therefore, in-service failures only majorly the railway systems is facing due to the presence of surface and subsurface defects. Therefore, it is essential to prevent failures originating from defects, some common defects to which rails are prone for. So some will be when we are repeatedly seeing the railway tracks are cracking, the wheel is getting friction will get wear concentrations and a crack may form due to heat involvements. So these are the common defects. So we have to check for those common defects and we can able to try to eliminate. Therefore, it is essential to prevent failures originating from defects. Some common defects are in the railways. See, some common defects: gauge face corners, tongue lipping defects, bolt hole crack, wheel burn, and foot cracks. These are all related to see the railway tracks and those wheel subject areas, bolt holes, wheel burns, or foot ray cracks. So those things all one by one we will see now. So number one, on that a gauge face corner. It is originated at a rail head due to high stress generated after the extensive pressure on the curved surfaces of rails and wheels. You see, somehow it is in the I section like it. Here we have a gauge face corner has been got in the crack. Likewise, it will form due to extensive pressure. So maybe tongue lipping defects. It's a result of existing crack only. It does not form additionally. As the when we can see when this above defect is formed, it means when this defect of a gauge face corner is formed, it will enlarge. Those defects will become the tongue lipping cracks due to frequent movement of high speed trains. If it frequently it moving even after crack formed, it means nothing but a vibration. If it is moved frequently again and again, the vibrations keep on acted on that specific location. Then immediately cracks is going to elaborate or extend. So that is called as a tongue clipping. This existing crack will grow bigger. So that is what it is, grow bigger and get transferred into the lip format of the surface of the rail. So here is the available defect. You see, this is the available defect on the left side image. At the same time, it become a tongue lipping defect. Tongue lipping defect, you see, it become enlarged due to vibrations and due to high speed movement of tracks. That is nothing but vibration. Bolt hole crack. Bolt hole crack. It is a result of extension of hole drilled into the rail for attaching two rails a fish plate. Due to excessive pressure impacted due to high speed trains, here also the vibration talks. Bolt gets enlarged and may result in detachment of fish plate and causing a big accident. We are attaching some cracks here, attaching some fish plate here. And due to this action of vibration or cracking movement at high speed, again this is getting losing. Therefore, the bolt is removed out of that, and otherwise the bolt itself getting cracked and broken. So this causes the accidents. So wheel burn. See, wheel burn. You see, maybe due to heating and wears, maybe due to the friction also. We'll see. It is originated due to friction between a rail and the track wheel. Rail, it means a wheel and the tracks. As a slipping of wheel takes place or the brake is being applied. The friction produces the heat and results in change in the microstructure of the rail may create cracks. So here we are not talking about a general crack. We are talking about the microstructural changes. Maybe from ferrite arsenate may converted into in the iron. It may convert into martensite due to high temperatures, or maybe it lose its property due to temperature going above the critical temperatures. So its matic particles will change. Matic properties will change when it is crossing the critical temperatures. So those things are all there. It differs with respect to materials too. So those things due to microstructural changes, definitely property changes. Maybe in good strengthening property to the brittle nature. So that causes a defect definitely. It causes the failure also definitely. The original structure and the change in structures happening. At last, the foot cracks. It occurs at the foot of the rail, not at the head. It is a head, it is a foot of the rail. The eddy current inspection exhibits some remarkable characters. So it is some remarkable characters by making it particularly used as an effective test method for rail surfaces. Advantages: with high sensitivity, even the smallest surface defects can be detected. Yes. A contactless operation can be done. Yes. It can use be very high speed. Definitely, this eddy current are possible to do. The rail examination is generally done with the test vehicles where eddy current test equipment is installed in two rail vehicles. The data is collected and the condition of rail rolling surfaces is evaluated and report is generated. This is generally first a trial and error method we are following. So done with the test vehicles, not at the service vehicles. We are doing it at test vehicles and then the data are prepared and compared accordingly. We frame the results. And we are using this and not only this eddy current, we are trying to do this ultrasonic testing also due to the safety purposes and accuracy conditions and the simplicity of ultrasonic testing method. It is brought in on forefront for inspection of the weld joints. For inspection of welds, a straight beam transducer with angle beam transducers and a wedge is used. We are using a maybe the straight beam transducer or maybe the angle beam transducer, and also along with this too we are using a wedge to be used. These are such components of ultrasonic. A straight beam transducer is used in presence of a laminar defect presence in the welds. So we know to define these laminar defects we are trying to use the straight beam transducer in the ultrasonic conditions. As angle beam transducers are insensitive to laminar defects and hence no reflection from the defect will be received. Instead of using these two, straight beam transducer, angle beam transducer, we use only the straight beam transducer. We are not using the angle beam. As the condition here is insensitive to the laminar defects, it may not reflect. So that is why we are using a straight beam defect in the ultrasonic inspection. Some interpretations we are trying to do here. So this is some photo image where how the probe is sending the signals towards this specimen. Here's a weld joint here, the welded V groove is taken under welded conditions. Maybe the laminar defects are forming here. You see laminar defects here. This one, and then we do inspection here. So angular distance we are doing some angular inspections and it reflects. Today, it is a phase of industrial and modernization where development of railroads plays a very important role. Since from the beginning of the development of railroads, it is always to be provided to various service failures. What are they? The failure in the railway track while they are in use. Maybe the failure happens in the railway track, or maybe in the railway wheels, or maybe in the railway loading conditions. So these are the chances are there. In case of high-speed traveling via railroads, failure railway track can be have a serious consequence of damages and accidents. So railway tracks is most important, both maybe the wheel or the loading conditions or maybe the tracks. So all these things are importantly we have to periodically do inspection. Formerly, inspection of rails was performed by means of visual inspections only, but later visual inspection is no use because the cracks are formed at the intermediate subsurfaces. Therefore, we went to UT or maybe other eddy current testing also we are trying to do. But with increase in high-speed rail traffics, heavier axle loads, you see, heavier axle loads, rail inspection is more important today than it has ever been since order reduce the catastrophic failures. As we know that defects in any components may be internal or maybe the external. External we can do in the we can able to do in this visual inspection, but at the same time these internal defects are not possible to do. So that's what the next point you see. External defects are done by the visual inspection. At the same time internal defects are done by the other methods like radiography and ultrasonic methods. This type of internal defects are called as transverse issues. So some example of transverse fisheries are wheelburn, scams, corrosions, inclusions, corner cracking, surface cracking, and tongue loping. So these are the a few various internal defects. Be welding inclusions. You know the tungsten inclusions during welding may come, or slag inclusions during welding may come, or maybe the corroded zones are not properly cleaned on the fairing surfaces of the V grooves. So there are chances are there. So this type of chances are to be monitored periodically. So this is how we it is formed there, right? So in this as a summary, in this total module we have seen various applications of NDT. Applications of NDT such as we have seen railway application of NDT in railways, application of NDT in aerospace, aircraft, an application of NDT in the automobiles, application of NDT in the pressure vessels, nuclear, non-nuclear and chemical industries, and at last we have seen today applications of NDT in the coal mining also, and we have seen some case studies, pictures, photos. So it will be very helpful to understand how this NDT plays the important role in the industrial sectors. The remaining part of the subjects we'll see you in the next session. Thank you.